Good morning everyone. In this video we are going to discuss about plant protection equipments. So what is plant protection equipments? So from what kind of thing we are protecting the plant? We are protecting the plant from diseases and pests. So we apply pesticides and herbicides. So by which equipments we apply this pesticides and herbicides? We use sprayers. So in this video we are going to discuss about what is sprayers, their components and different types of sprayers used. Sprayers. Pests and weeds are playing a significant role in productivity losses. In modern agriculture practices, pesticides and herbicides are mostly used to control the pest and weed growth by the spraying equipment. Sprayer is a machine used to spray liquid chemicals on plants to control pests and diseases. It can also be used to apply herbicides to control weeds and to spray micronutrients to enhance plant growth. The process of spray liquid droplet size or breaks into fine droplets is called automation, in which can be achieved by using the different types of nozzles and operating pressure. Functions of sprayers. It breaks the chemical soil into fine droplets of effective size, distributing the droplets uniformly over the plants or trees, applying the chemicals with sufficient pressure for positive reaching of the plants, resulting the amount of liquid applied on plants to avoid excess application. Basic components of sprayer: pump, chemical tank, agitator, air chamber, pressure regulator, valve, strainer, suction line, delivery line, and nozzle. So let's see in detail about each component. First, pump. It is a device used to move fluid such as liquid or slurry or gases from one place to another. A pump displaces a volume of physical or mechanical action. Most hydraulic sprayers are equipped with positive displacement pumps capable of developing pressure required for many spraying jobs. The discharge capacity of these pumps is approximately proportional to the speed. A pressure relief valve or bypass valve is required to protect this positive acting pump from damage when the discharge line is closed and for the convenience of the operator. Tank. It is the container to hold the chemical solution. It is made up of PVC, brass, etc. It is usually made up of metal sheet or synthetic rubber or plastic, having good resistant quality against the corrosion, erosion and similar action. The size of the tank varies according to the pump capacity and the requirements. Agitator. It is a device which stir the soil solution and keep the content in homogeneous condition. Positive agitation of spray material in the tank is essential to permit using the full range of spray materials, including powdery emulsion, fungicides, cold water paints, or other spray material. The propeller or pedal type mechanical agitator or hydraulic agitator are very common. Air chamber. In a reciprocating type pump, an air chamber is provided on the discharge line of the pump to level out the pulsation of the pump and thus providing a constant nozzle pressure. Pressure gauge. And a dial gauge which indicates the pressure at which the liquid is delivered from the pump. A pressure gauge properly calibrated within the pressure range of the pump is provided on the discharge line to guide the operator for making proper adjustment of pressure at site. Pressure regulator. The pressure regulator serves several important functions. It is the main mean of adjusting the pressure as required for any spray job within the pressure range of the pump. When the positive displacement type of the pump, it also serves as the safety device in automatically unloading the excess pressure by directing the unused discharge flow from the pump back to the tank. Valves. A valve is a device that regulates the flow of fluid by opening, closing, or partially obstructing various pathways. Cutoff valve is provided in the delivery line to control the flow from the pump. Bypass valve is provided in the delivery line to bypass the flow from pump to tank when the flow in the delivery line is reduced than the pump capacity. Relief valve. It is an automatic device to control the pressure of fluid or gas within the range of predetermined pressure. Strainer. It is a small circular plastic ring with nylon wire mesh to filter any dust particles coming with the chemical solution. It is included in the suction line between the chemical tank and check valves. In some sprayers, strainers are provided at the mouth of the tank. Example, knapsack sprayer. Nozzles. It is a component which breaks the fluid into fine droplets. Atomization of spray fluid is usually achieved by discharging the liquid through an orifice called nozzle under pressure. Atomization is also achieved by breaking up the jet of liquid with a blast of air. Type of sprayers. Based upon the volume of liquid handled, sprayer can be classified into high volume sprayers more than 400 liters per hour. Low volume sprayers 5 to 400 liters per hectare. Ultra low volume sprayer sprays less than 5 liters per hectare. The selection technique will depend upon the type of vegetation, kind of pest, and approach to the field. Hand compressed sprayer. The hand compressed sprayer is small, light, and compact unit. It consists of a container of 0.5 to 3.5 liter capacity. This is generally used for spraying small areas like kitchen garden and experimental laboratory plots. It is an hydraulic energy sprayer. It has an hydraulic pump inside the container with cylinder, plunger and a plunger rod. By operating the plunger up, the spray fluid in the container is stuck into the cylinder through an ball valve assembly and then pressurized through the downward tube. The pressurized fluid is then let out through a nozzle and sprayed into the fine droplets. If the pressure to, to be built inside the container, an air pump with cylinder, plunger and plunger rod is required. When the plunger is pulled up, the air is stuck into the cylinder and when pushed down the air bubble is released into the container with 80% of its volume filled with the fluid. The air reaches the space above the free fluid surface and presses the fluid. The pressurized fluid is drawn up through an tiger cut-off valve to the nozzle where is atomized and sprayed. In some other type, air pump and the container are separate pieces and the pump is attached to the container in such a way to release the pressure air through an orifice at the top of the container. The fluid is lifted through an orifice at the top of the container. The fluid is lifted through an capillary tube due to surface tension developed by the high velocity air at the outlet and sheared away by the air and sprayed as droplets. Bulk module. Bulk module is equal to pressure applied divided by a fractional change in volume. Unit Pascal. K is equal to minus V dpy divided by dV. K is bulk modulus, P is pressure, V is initial velocity of the substance. Compressibility. Compressibility is the reciprocal of bulk modulus, that is 1 by unit is per Pascal. Compressibility is denoted as beta is equal to minus 1 by V dou V by dou P. Bucket sprayer. A pressure of 4 kg per square centimeter is developed in most of the models. The bucket sprayer is usually to pump the spray fluid directly from the open container, usually a bucket. The hydraulic pump will be put inside the bucket and held properly with the help of footrest. As the plunger is pulled up, the fluid enters through the suction valve assembly, and when the plunger is pressed down, the suction valve closes. The fluid enters the pressure chamber through an ball valve assembly. As the plunger is continuously worked, pressure is built in the pressure chamber and the delivery hose. As soon as the required pressure is built up, the spraying will be done. Knapsack sprayer. Any sprayer which is carried on the back of the operator is called knapsack sprayer. The commonly used manually operated knapsack sprayer will have one hydraulic pump working inside the container. The pump is operated to pump air into the tank to build pressure up to 2 to 3.5 kg per square centimeter. The plunger works inside the replacement well attached to the bottom of the container for easier maintenance. The pump can be operated through the appropriate linkage by oscillating the handle with the sprayer carried on the back. An agitator is also provided with the pressure chamber to agitate the fluid so that the particles in suspension will not be allowed to settle down. The delivery tube is attached to the other end of the pump, which carries the pressurized fluid to the spray lands. The flow of the nozzle is controlled by a trigger cut-off valve. In the case of compression knapsack sprayer, an air pump is used to build air pressure above the free surface of the spray liquid in the container, and normally the pumping of the air will be done by keeping the unit on ground and then spraying till the air pressure comes down. The unit is again brought back to the ground for pumping air, and then the spraying is continued as before. The spray fluid, which does not require any agitation, only can be sprayed by using this type of sprayers. The application rate ranges from 45 to 100 liters per hectare. Rocker sprayer. Rocker sprayer is mainly used for spraying fruit trees in orchards, coconuts trees, flower gardens, and cotton and tapioca field. It consists of a piston type pump, a platform with fork, a lever to operate the pump, pressure chamber, suction hose with strainer, delivery hose, and a spray gun with flow control knobs and nozzle. The pump pulls up a pressure up to 1.4 to 1.8 kg per square centimeter, which facilitates the use of sprayer for tree spraying. The pressure chamber helps for continuous spraying. The chemical is taken in a separate container and the suction hose is kept in the chemical container. When the pump is operated, it draws the fluid through the suction hose and delivers it to the delivery hose through the pressure chamber. When the flow control knob is turned, the fluid is sprayed through the nozzle. The output of the sprayer is 70 to 90 liters per hour with one nozzle. Coverage is about 1.5 hectare per day. The rocking sprayer has a pump assembly fixed on a wooden platform with an operating lever, a valve assembly with two ball valves, a pressure chamber, suction hose with strainer, and a delivery hose with spray lance. When the plunger is pulled behind up, pulling the lever away from the pump, the spray fluid from the container is sucked through the strainer and pushes the bottom valve about and enters the pump. The movement of the low ball valve is arrested by the upper valve seat. When the lever is pushed towards the pump, the sucked fluid is forced to enter the pressure chamber by opening the upper ball valve. The operation is continued till the entire suction pipe, ball valve assembly, delivery hose, and portion of pressure vessel is fitted with spray fluid, and the pump operator find it difficult to push the piston forward due to the downward pressure developed by the entrapped compressed air in the pressure vessel. Thereafter, the trigger cut off the valve with the opening opened it therefore the trigger cutoff valve will be opened to allow the spray fluid to rush through the nozzle and get atomized. Usually 1.4 to 1.8 kg per centimeter square pressure can be built in the pressure chamber and hence can be conveniently used for spraying. Foot or pedal operated sprayer. The foot or pedal sprayer, as they are commonly called, consist of a plunger assembly, stand suction hose, delivery hose, spray gun with a nozzle, etc. One of the suction hose is fitted with a strainer and the other end is connected to the pump inlet opening. Similarly, the delivery hose is fitted at one end to the delivery opening of the pump and the other end to the spray gun. Constant pedaling is required for continuous spray. It develops a pressure of 1.7 to 2.1 kg per centimeter square. The chemical is taken in a separate container and the suction hose is developed in the chemical container. When the pump is operated by the foot, it draws the fluid through the suction hose and deliver it in the delivery hose. When the fluid control lever is pressed, the fluid is sprayed through the nozzle. Agitation of the chemical solution is done by supplying a portion of the air from the blower. The discharge rate with one nozzle is 1.10 to 1.35 liter per hour and coverage is 1 hectare per day. Knapsack motorized mist blower cum tester. It is the simplest engine-driven sprayer used in agriculture. It is carried on the back of the operator. It is used for spraying to all type of field crops, most popularly to paddy, groundnut, cotton and vegetable crops. It consists of 1.2 to 3 HP high-speed petrol engine, a blower, a 1.2 liter chemical tank, delivery hose, fleeted air hose, flow regulator knob and plastic atomizer grate. The tank is filled with the liquid chemical solution. When the engine is started, the blower generates a high velocity air to which the chemical solution is fed. The chemical mixed air stream is broken into fine droplets at the atomizer grate and sprayed. By changing few parts, the sprayer can be converted into tester. Spray droplet size determination. Spray liquid is atomized into unequal size of droplets by the spraying equipment. This droplet spectrum can be measured to determine the amount of chemical used. The most widely used droplet size parameters are volume median diameter and number median diameter. The unit used to measurement of droplet size is micron. Volume median diameter VMD. It's a diameter of droplet which divides the volume of the spray into two equal halves. A representative sample of droplets of a spectrum is divided into two equal parts by volume so that one half of the volume contains droplets smaller than a droplet whose diameter is the VMD and the other half of the volume contains larger droplets. Number median diameter NMD. The number median diameter is the diameter of droplets which divides the number of droplets into two equal halves. The NMD is the average diameter of the droplets reference their volume. Next is drift. It is a continuous slow movement of spray liquid apart from a targeted area by a current of air. So, how to minimize drift? Consideration of meteorological condition, proper distance between crop and atomizer sprayer closer to the plants, use soft hoods and shields, protection of large droplets, reduce concentration and increase discharge rate. So in this video we have discussed about different types of sprayers and components of it and its uses. Thank you.